Hello and welcome to the new chapter, Real Numbers. When you are preparing for the examination and when you are preparing the chapter Real Numbers, for the long answer type, one of the topic that you have to thoroughly revise is how to go for the proof of irrational numbers. Let us see an example. Prove that square root of 3 is irrational. Here what we have to do is we have to assume the given irrational number as a rational number. Suppose root 3 is a rational, which implies root 3 is equal to p by q. When you are writing a rational number in terms of p by q, you should remember the p and the q are the co-prime numbers. It means their HCF is 1. Squaring on both sides, we get 3 is equal to p square by q square, and by cross multiplying 3q square is equal to p square. By the fundamental theorem, we say 3 divides a p square, which implies 3 divides a p. Since 3 is a factor of p, we assume the p as a multiple of 3. So we assume it as a p is equal to 3k. Therefore, we write the 3q square is equal to 3k square, that is a substituting in this step. So we get 3q square is equal to 9k square. The 3 common factor, it gets cancelled, and we get q square is equal to 3k square. So here we say 3 divides the q square. Again, by the fundamental theorem, we say 3 divides the q. If you take this equation 1 and equation 2, we notice that the 3 is a common factor of p and q. Already we have said the p and q are the co-prime numbers, but the co-prime numbers, their HCF is 1. In other words, they don't have any other common factor except 1. But we are having the 3 as a common factor of p and q. It contradicts the fact that p and q are co-primes. Hence, our assumption the root 3 is rational is wrong, and hence root 3 is irrational.